I am recording. Okay. Yes, so we're good to go. All right, here comes Sarah, and I'm going to watch everybody as they come in. But I'm going to start out with the PowerPoint. I'm going to share my screen. And again, this is just kind of a framework for us to get started tonight, okay? I'm starting to get things in my head. I have to have things make sense. Things have to make sense and make sense in the real world for me to really comprehend them. And so now from this class and really looking at where y'all been and where we're going, I think I have a good game plan. So I'm feeling a lot more confident now moving forward. So hopefully that'll translate for you guys too. So let me share my screen here for my. Okay, so this is, again, just going to be a snapshot review of the things that we've already talked about. Variable levels, what descriptive statistics are, what they do, the inferential statistics, and just a brief touch on those model assumptions, because we're going to be going back and forth between those model assumptions, because they really do apply to things like multiple regression, and they apply to the principal component analysis, the factor analysis, not as much to some of these other statistical tests like t-test or ANOVA, because those are fairly robust to handle some of those assumption violations. But as we move into those more complicated ones, we'll also be looking at those more in depth. So just to start with, it's important, again, that you understand the different levels of measurement for your variables, because that tells you what statistical test you can run. The nominal level, of course, is the one that has no mathematical to it. I always say it's categorical, but that's not totally the correct term to use. But it's the things like political party affiliation, and it's gender, and it's the things that we use words to describe. And really out of that, about the only thing you can do is counts. But tonight we are going to look at being able to do a chi-square to look at some relationship between those variables. But again, we use a lot of nominal level data in the work that we do. So it's important that we have some tools in our toolkit to be able to do some analysis of those. The ordinal level data, again, the most common one for this can be seen as the Likert scale. We always do the strongly disagree to the strongly agree, something along those lines, to get that 1 to 5 or 1 to 7. When we're doing statistical analysis, the ordinal level data, there's gray areas with it. Nominal level data, we actually know we cannot do mean, median, those, we can't do the mathematical quantifications with the nominal level data. When we have ordinal level data, that gets controversial. And it depends on which statistical book you're reading or which statistical guru you're listening to that says you can use ordinal level data like you do interval ratio or not. Kind of the accepted rule of thumb is if you're wanting your ordinal level data to be able to use this interval ratio, you need a minimum of 7 ratings. So you need 1 to 7 or 0 to 6, something along those lines, to be able to count this as an interval ratio level data and do some of those higher level statistics with it. There's others who tell you you absolutely cannot do that with ordinal level data, and you really treat it like nominal level data. So it's very gray in terms of how you use that. What you'll find a lot of times, and what I find a lot of times in my research, is when I include those ordinal level scales and I have strongly disagree to strongly agree, unless I have a very large sample, usually what happens is I don't have a lot of variance in there, meaning that my strongly disagree and my disagree, I'm not going to have a lot of variance between the two. I may have 10% they say strongly disagree. I may have 45% that say disagree, and I may have 10% that say strongly agree, and I may have the rest of them that say agree. And what that tells me is I don't have enough variance to really run any meaningful statistics between those categories. So I end up collapsing them. And then I end up with a nominal level variable, agree, disagree. Again, you have to make those decisions when you get your data, but that's one thing that I'll also show you how to do to recode some variables if you need to do that. But just know ordinal level data kind of falls into a gray area, but oftentimes we will be using it like we do nominal level and not necessarily at the interval ratio level. When your variables are interval ratio, that's when you can actually do all the mathematical computations. And when we talk about running independent t-test, dependent t-test, ANOVA, multiple regression, all of those, the formulas that you use require a mean. They have to have an average in that formula. That's why you have to have data at this level to actually compute those statistics, because it's the formulas that they use that they require that mean. So if your data, if you can't get a mean in your data, it's not going to be appropriate for those type of statistical tests. And again, we treat interval ratio really the same in behavioral sciences. We don't differentiate between the high level of whether it's interval ratio and whether it has the meaningful zero or not. You'll pretty much find all the time we pretty much treat those the same. So it depends on the level of your variable, and it's really important that you can make those distinctions, because again, an example, if I say, if I want to use age, I can measure age in my participants at any one of these levels. At the nominal level, I could say, I could ask the question, are you over the age of 65? Yes or no? Maybe that's the pertinent question I need to ask, but that's at a nominal level. I could ask, I could categorize my ages, and I could say, indicate the group, indicate where your age falls below. And I can say 18 to 30, and then I can say 31 to 49, and then I could say 50 to 68. I can categorize it however I need to. Then it becomes ordinal. Or I could do interval ratio, and I could say, how old are you today in years? And just have them put that number down. At any point in time when you're constructing your own data collection tool, you want to try to capture your variables, as many as possible, at that interval ratio level. Anything you can capture at the interval ratio level fairly easily, you want to do that. So if it's annual income or household income, try to avoid using the categories of ordinal. And the reason being, when you have the interval ratio, we've already seen we can run more statistical analysis. We can do more sophisticated statistical analysis if we have that level of variable. And if for some reason we need to take that level of variable and move it, make it an ordinal or a nominal, we can do that. We can go backwards, we can recode our variables, and we can do that. If we only capture it at the nominal or ordinal level, we can't expand it back out and make it interval. So anything you can capture at the interval ratio level, you want to do that, because you can always collapse it down if it doesn't work the other way. But if you don't capture it at that level, you limit the statistical analysis you can do. So brief review of levels of measurement. Is everybody good with that? Any questions? Okay. In descriptive statistics, and we've talked about using the descriptive statistics, and no matter what data set you're using, no matter what data you collect, you always run your descriptive statistics on all of your variables, because for two reasons. Number one, this is how you actually take that information and your sample. What were their ages? What were their age range? What was the gender? What was their depression scores? What was their cigarettes they smoked? Whatever it is, those descriptive statistics give you that snapshot of your sample population. The other thing about descriptive statistics is we can actually use those to look for some of the things we need to look for in terms of our assumptions or cleaning up our data. Do we have missing data? Do we have outliers? Those are two big things that we can look at in our descriptive statistics. We can actually do some correlations and see if if our variables are correlated to the point that they need to be correlated for us to run more sophisticated. But you can always run descriptive statistics no matter what it is. And in descriptive statistics, basically we've got the mean, the median, the mode, and that's for interval ratio level data. We have case counts for nominal level data and ordinal level data. So we have some basic things that we can run to make those descriptions, okay? Then we have the inferential statistics. And when we get into inferential statistics, that's when we're actually trying to talk about relationships between variables or draw more conclusions. And that's where we run things like correlation in terms of, is it a significant correlation? What's the direction? We do the t-test, we do the ANOVA, we do our regression, we do our chi-square. Those are all of our inferential statistics that we can run depending upon what relationships we're looking at and what level our variables are at. Uh-oh, who is that? So nominal and ordinal level data, again, at descriptive statistics, it pretty much gives us case counts. And it can even, if you're looking at strongly disagree to strongly agree or whatever that is, you can actually even, you know, what's the percentage of the individuals who strongly agree with this statement versus the percentage who don't. So that you can get those case counts. In descriptive, we're going to get oftentimes the median. If we have nominal or ordinal level data, we might be able to get the median out of ordinal level data and the mode out of nominal level data. What is reported the most? In inferential statistics with nominal and ordinal level data, we can actually use chi-square. And that's what I'm going to give you an example of tonight is the chi-square. So we'll go through that. And again, that's nominal level data for chi-square, or if you have some data that doesn't meet the assumptions of some of the other tests, you might be able to do a chi-square. Again, if it's ordinal interval ratio level data, and ordinal's gray, it's the gray one, so it can fit into the nominal level or it can fit into the interval ratio level data. But descriptive for ordinal interval ratio level, it can be the mean. Anytime you have the mean, you always report your standard deviation. It can be the median. Anytime you have your median, you want to report your ranges. And it can be percentiles. You know, the 25th percentile, the 50th percentile, the 75th percentile. We can look at any of those from the ordinal and interval ratio level data.
Dr. Judd?
Yes.
I think Erica is trying to get in. She hasn't been able to get into the class.
I don't have anybody waiting. I don't know.
Okay. I think she may have gotten the wrong link. I'll tell her which link to use. I'm sorry to interrupt.
That's okay. Yeah, it's going to be either in the D2L or the one I sent out. Let me know if she still has a problem. I'm not sure how to fix it, but let me know.
Okay, I will.
Okay. Okay, so ordinal and interval ratio level data, we can do more inferential statistics with that than we can with our nominal. Obviously, we can do the correlation. We talked about Pearson's R. And here comes another one. So this answers the question, is there a relationship between two variables? And if so, what direction and strength is the relationship, and is it significant? So for inferential statistics, again, ordinal, you might be able to do this. Interval ratio, you always can do this. Both the variables have to be at the interval ratio. So correlation, are the two variables correlated? So what's the direction, what's the strength, and is it significant? We did the independent samples t-test last week. And that requires 2 independent categories, okay, and 1 scaled variable. So in the 2 independent categories, I say it can be nominal or ordinal, but you have to have categories where individuals aren't going to be duplicated. So that means that male and female in your population. Or if you do have strongly disagree to strongly agree, agree, disagree, you could actually compare those 2 categories as long as the individuals could not be in both of them, as long as one participant couldn't be in both of them. Both categories that you're comparing need to be independent, okay? It's for the independent samples t-test. The question this answers, is there a difference on the measure of depression? Is there a difference on the measure of anxiety? Whatever you're measuring between groups or the participants A and groups or participants B, and is the difference significant? So that's what we're going to answer with the independent samples t-test. So we're going to have 1 variable that's going to have categories. So it's going to be a nominal level variable or an ordinal level variable. And we're going to have 1 variable that's going to be at an interval ratio level. And that's what we're comparing them on. So you can always think of this as like IQ test, comparing boys and girls on IQ test, or comparing men and women on alcohol intake, something like that. That's your independent samples t-test. The dependent samples t-test, and we're going to run through this tonight, is 1 category, nominal or ordinal, okay, and 1 scale test, but 2 measures. So this is always a pre-test, post-test, okay? So you're actually comparing the same individuals who take the pre-test and who take the post-test. So maybe this is females in 8th grade, and you're giving them a bullying questionnaire and you're providing an intervention, and then you're doing a post questionnaire, and you're going to compare them on the pre and the post test. So it's the same group of individuals, but it's measured twice. Almost always this is used for pre-test, post-test in what we do. The ANOVA, which we went over last week, 3 or more independent categories and 1 scaled variable. It does what independent samples t-test does and answers those questions, except for 3 or more groups, basically. So it's the same qualifiers, but you're just looking at 3 different groups. Regression, which we've done simple regression and we've looked at multiple regression. And in regression, you have 1 dependent variable, and then you have 2 or more independent variables that you're regressing onto it to see how they contribute to that dependent variable or the variance in that dependent variable. So 1 dependent variable at a scale level and 2 or more independent variables at a scale level or a nominal level if you use the dummy coding. So any of those inferential statistical tests you can run with your ordinal interval ratio level data. So see, you can do so much more if your data is at that higher level. The assumptions that we've gone through and just basically touched on, we haven't gone into them in depth. It's assumptions and it's cleaning up your data. So it kind of takes care of both of those. You always want to check for the missing data and the outliers. Those are 2 things you check all of your data for to determine if those are there. And that can be done again through those descriptive statistics. Here comes Erica. Visually, you can look for normality on scale variables, that normal distribution. That's going to be important in multiple regression. It's going to be important in your t-test if your variances are normally distributed. The homogeneity of variances, we touched on that last week when we did the independent sample t-test, because it's the Levine's t-test and it tells you which one to choose based on the homogeneity of variance or not. And then if you're computing multiple regression, you want to check for linearity, multicollinearity, homogeneity of variances across all groups. The multicollinearity, when we looked at that last week, we looked at those collinearity diagnostics. When you have multicollinearity, this is when, because in regression, you want your independent variables to be correlated with your dependent variable. So you want each independent variable that you're checking with your dependent variable to have a correlation. You want them to move, okay? When the independent variable changes, you want the dependent variable to change. What you do not want is you don't want your independent variables correlated with each other, because you could actually be measuring, you could be counting two variables, but be measuring the same thing because they're so highly correlated. That's multicollinearity. When we start talking about principal component analysis, factor analysis, this is one thing that does, if you're developing a measurement tool, is it identifies the multicollinearity so you can eliminate it. And we'll talk a little bit more about that. It's not a reason to do factor analysis or principal component analysis if you have multicollinearity in your multiple regression. That's not a reason to do it, but that is a reason to do it if you're actually developing a scale to measure something. So we're going to keep going over and over the assumptions as we do the test so that there'll be a better understanding of those. But I want you to really get an understanding of what tests to run to answer which questions and look at which relationships. I think that's going to be really important, because once you have that down, then it's very easy to go back and look up what are the assumptions if you don't remember it off the top of your head. And you're not going to. I have a checklist I have to go through. I just don't remember it off the top of my head unless you just, that's all you do is run statistics. So tonight we're actually going to again run a chi-square. We're going to run a dependent samples t-test. I'm using the same data we used last week, except I sent out an updated version because I had to add a pre and post test to that so we could do the dependent samples t-test. Okay. So now I'm going to bring up SPSS and I'm going to run those two tests. We'll go through that. If anybody has any questions, please just speak up and let me know. Okay. So let me go to a new share. This one. Okay. You should be able to see my data. Can you see my data? My SPSS data?
Yes.
Okay. All right. So what we're going to do to run the chi-square is we're going to look at, what did I look at? I looked at gender and I think I looked at gender and education. Let's look at gender and education. So for gender, which they labeled as sex, we have male and female. For education, we have, what are our groups? Oh, we can do the education recode because they recoded it into, yeah, did not complete high school, completed high school, additional training, undergrad. So let's run a chi-square and see if those two variables are independent of each other. And what that means is, in our sample population, is the level of education going to be dependent upon the gender of the participant? So let's see what we get. So we're going to go to Analyze. We're going to go to Descriptive Statistics. And then we're going to select crosstabs. So we go Analyze, Descriptive Statistics, crosstabs. And when we open crosstabs, we get this, and we have rows and columns. Okay. So let's put gender on the row. And I'm going to go down here and put the recode, the highest education recode, on the column. So my rows are going to be gender, my columns are going to be education. It really doesn't matter the order that you put these in. Sometimes it's easier to read if they're reversed, but you may not know that till you run it to begin with. But there's no specific reason to put these in any specific order here for your rows or your columns. We're going to go to statistics, and we're going to check chi-square up here at the top. That's all I'm going to check right now. We're going to go to sales. You click on sales. The sales is going to give us our observed. What chi-square does is it checks the observed number, the actual number in the sales, against the expected number in that cell if there was no difference between the groups. Okay, so I typically don't put expected in my output. You can. I just use observed. I also use row, column, and total percentages because this helps you understand the output a little bit better if you put those in there. So then I'm going to hit continue, and then I'm going to hit OK. Okay. This right here is what we get when we get the output for our chi-square. We have 439. That was our total right there. We have the row is our males. Row is our females. Column is our did not complete high school, completed high school, some additional. Okay. Down here, it tells if we have significance or not. The chi-square test. And you look at this Pearson chi-square across the top, and you got a 0.005 right here for the asymptotic significance. That's what we look at. So we do have significance. So what this tells us is that gender and education is not independent in our sample. They're somehow related in our sample.
Dr. Judd?
Yes.
I'm sorry. I'm not, are you always?
Oh, you know what? Here we go. Oh, y'all have to holler at me. Is that better? Now you got the output? Okay, all right. Y'all holler at me, slap me, do something. So don't forget. Okay, so this is the output. This is what we get. So right here we have our case processing summary. So we have sex with education is 439 right there. This right here says 440, and I'm going to tell you the reason it says that is because I accidentally put an extra one in here when I did that. And even though I took that number out, SPSS still counts it. So anytime there's a dot in a blank cell, it counts it as being a case. So I didn't go back and actually clear that. There's a way to do that. But 439 is actually the accurate total. There is not anybody missing here. That was my mistake down there at the bottom. So right here in the rows, we have males and we have females, and then we have the total count. So when we look at this first one, did not complete high school, we have 12 males who did not complete high school, which is within the males, that 6.5% of the males in this did not complete high school. Within those who did not complete high school, 21.8% were males. So you see how you get your percentages here differently. So in the did not complete high school, for the whole sample who did not complete high school, 21.8% were men. Of the whole sample who did not complete high school, 78.2% were women. So in this particular sample, the majority in that did not complete high school were females, right? Based on this. So that's how you read this. If we go over here to those who completed high school, there's a total of 38 males completed high school. And within the education of the total population of the ones who completed high school, 44% were males. and 55% were females. So if there's a slight increase in the females who completed high school compared with the males for those in that category. Okay, there were a total of 85 out of the sample who did not complete high school. See right here at this bottom, total of 85 did not complete high school. So that's how you can read that. So you can see these percentages. Even if you don't run the chi-square, even if you're just wanting to divide up your categories to see how your sample falls within those different categories, you use the cross tabulations to do that. Because I can provide a whole lot of description right here about my sample just based on this cross tabulation and dividing up the males and females into these two, right? But what I can say is that there is a relationship. There is a significant difference between males and females in terms of the education, because it is significant right here. Any questions about that?
Yes, can you like sort of interpret that again for me?
I can.
So a significant value like on the Pearson chi-square means what?
Means that there is a relationship between educational attainment and gender. They are not independent of each other. So there's some meaning behind the fact that the majority of those in our sample who did not complete high school were women. Or the majority of those with some additional training were women. So you go back and you look and see where your percentages lie, and then you know that there's some type of meaning behind that because it is significant. So they're not independent of each other. If it was not significant, then we would be able to say education attainment and gender had no relationship.
And it's taking the whole variable with all the levels with the other variable with all the levels and indicating
Yes.
a relationship.
Yes. And this is nominal level. So it's the categories within the nominal level variables that it's looking at. Okay. So we have males and females, and then we have each category of educational attainment, and it breaks that down and looks at how many males and females fall into each of those categories. And what chi-square does is it looks at the observed. This is the observed, so this is the actual number of individuals who responded this way, and it compares it with what would be expected. Okay, if there would be expected, if there was no difference between males and females in educational attainment, you know, if it was not significant. So what would we expect versus what did we observe? And because what we observed, because chi-square tells us what we observed, differs significantly from what we would expect, so that we have some type of meaning that's going on here between the gender and the educational attainment. Any questions?
And so if I just wanted to look at like, well, I think I'm asking a dumb question and maybe just answer.
No dumb questions. Go ahead.
So if I like wanted to look at just like a specific category with another specific category, I mean, ultimately that would just go back to a regular Pearson's.
Only if it's at an interval ratio level.
Oh, okay. So if I would, it doesn't matter if I wanted to take just one category from education and look at gender, right? I mean, it would still come out as a Pearson chi-square.
Down here at the bottom. Well, okay. Yes and no. So if you just wanted to take, so you're just interested for whatever reason in those who completed their undergraduate degree. So you're just interested in those who have completed your undergraduate degree between the males and the females. Okay. So you could just report what it has right here, because it's still going to take in all the categories when you run the cross tabs. Okay, the cross tabs is what you're looking at, because cross tabs are going to cross all those categories. If you click chi-square, that's going to tell you if it's significant or not. Okay, so you're doing two things. You're actually looking descriptively at your categories and how they cross each other. And then you're also doing the statistical test to see if there's a significant difference in those two. Okay, so the chi-square test here, this Pearson chi-square, this is a Pearson chi-square, so it's not the Pearson correlation that we get when we run the correlation for interval ratio. Okay, so it uses a different formula here.
Okay, so the single statistic of chi-square both determines correlation and also compares it to what would be expected if they were just two totally unrelated things, entities, categories.
It does. Yes, okay. Yes, it does. Yes, right there.
Thank you.
You're welcome. So it gets kind of confusing because it says Pearson chi-square versus the Pearson product moment coefficient, which is what we actually get out of when we do the inferential running of correlation, and it's both interval ratio. So they're two different formulas, but apparently the same person came up with them. Okay, and then on this one, this Pearson chi-square, because it is significant, that's for all the categories. Okay, it's not just on any one. That says that there's a significant difference between males and females with gender, with educational attainment. But anytime, if you're just running descriptives, even if you're not interested if it's significant or not, but you're just wondering how your categories break down across two variables like that, you can just run the cross tabs. You don't necessarily have to run the chi-square. The cross tabs still give you this middle table right here, this recoded cross tabulation. It gives you that and how things fall together. Any questions? Okay. So I'm going to go back to my data, because the next thing I'm going to show you is the dependent samples t-test. Okay. Now we had done the independent, or we did the independent samples t-test last week, where we just looked at the two categories, the two independent categories on the one variable. So tonight we're going to do the dependent samples t-test, and the dependent samples t-test, like I said, almost always encompasses a pre-post test. It's almost always a pre-post test. Okay. So I added a before treatment and after treatment to this particular data set, since that's what we're using. So we're going to say all 439 of our participants took the pre-treatment test and then took the after treatment test. So in this particular situation, we were actually rating them on tolerance of individuals from other ethnic backgrounds. And the scale goes from 0 to 50, 50 being, I don't remember if 50 is most tolerant or intolerant. We'll see. I don't remember. The scale's from 0 to 50. That would be important to remember, wouldn't it? If the higher score is tolerant or intolerant. I honestly don't remember. I'd have to look it up. But but I want to show you how to do the dependent samples t-test, okay? So we're going to go to analyze. We're going to go to compare means, because we're comparing the mean of the pre-test with the mean of the post-test for the one group. The one group is all 439 participants. And we're going to go to here. It's called a paired samples t-test. So you click on paired samples t-test, okay? And we're going to say variable 1 is going to be before treatment. Move that over. Okay. And we're going to say variable 2 is going to be after treatment. Okay. And we have just one. It's going to be for everybody. We've got estimate effect sizes. That should be, let's see here. I have not run this. I just put this data in, so I honestly don't know how it's going to turn out. We'll all be surprised. Okay. So we have a paired samples t-test. So we have 439 in here. We have a significance.
We don't see your output window.
Oh, okay. Thank you. Thank you. Thank you. New share. Okay. I think this is it. Do you see paired sample statistics? Okay. So paired sample statistics, we have 439. Before treatment, the mean was 32.87. After treatment, the mean was 36.96. So based on this, we're going to say higher scores mean more tolerance, lower scores mean less tolerance, because we want our intervention to have been effective, right? We want more tolerance after the intervention. So it is significant at the 0.000 level. We see this right here in this second table, okay? And right here, the paired samples test is actually, we have a mean before and after treatment, a difference of a negative 4.08656. There's our standard deviation, okay? There's our significance, there's our degrees of freedom, and there's our t-statistic. All we have to remember in here is that we have to report our t-statistic, our degrees of freedom, our significance level, and our mean change, the mean difference. So what we were able to show here with these three tables right here, I'm not going to go into effect sizes. We'll talk about that later because that goes over into another area. But we'll talk about the paired samples t-test, paired samples correlation, paired samples t-test right here, which actually gives you all of your numbers that you need. We can say that our treatment was successful, that we provided an intervention to increase tolerance for those of other ethnic backgrounds, and that we saw a significant increase in the mean score between before our treatment and after our treatment. And there was a decrease, significant increase, that's correct, before and after treatment. So we saw a significant increase in the mean score towards tolerance after our intervention. Therefore, we're going to say our intervention was successful in creating increased tolerance of our participants towards individuals who had different ethnic backgrounds from them. So that's the dependent samples t-test. It's really that simple. Any questions? So you now have in your toolkit a chi-square, a dependent samples t-test. You have your independent samples t-test from last week, your ANOVA. We've done your regression, simple linear, multiple regression. We've done the descriptives. So right now you got a pretty good toolkit, don't you? It's getting better? Okay. And those right there, honestly, in terms of the work we do, social work, counseling, even psychology, those are the main statistical tests that we really do use all the time, is our t-test, our ANOVA, our regression. If you're going to get into more sophisticated type of research to do, develop measurement tools to, break down some latent type variables, you'll get into factor analysis, principal component analysis. But these other tools are the what I can tell you from my experience are the ones that we use almost all the time in terms of the statistics. The factor analysis, principal component analysis, the MANOVA, all of those are not used as often in what we do. They're still very useful, but they're not used as often. So these are the ones I really want to make sure that you get a grasp of. And then we will also explore the others. But if you come out of the class with a grasp of these first statistical tools, you'll have a good foundation moving forward. Okay. So let me just introduce you, if you're not overwhelmed enough, let me introduce you to factor analysis, principal component analysis. We're not going to run it tonight. I just want to introduce you to the concept. I know you have the assignment where you're going to be comparing two different research studies. One is going to be a qualitative, phenomenological type of study, and one's going to be factor analysis or principal component analysis. What I can tell you is obviously one's qualitative and one's quantitative. The qualitative one gathers that lived experience and looks for the patterns and the trends and the things to generate categories or to generate hypotheses that can then move into a quantitative type measurement, okay? Principal component and factor analysis actually takes latent variables, which is kind of what qualitative research investigates, is latent variables. And what that means is those are concepts that we really can't measure directly. Happiness. Can we really measure happiness directly? What's another one? Maybe physical health, maybe something like that. So qualitative looks at an in-depth subjective impression of that latent variable. Tell me what happiness is for you. And you do those in-depth studies and you start seeing patterns emerge. Factor analysis, principal component analysis takes quantitative data that's actually already been quantified in some way or measured in some way, and looks for patterns in it. So one of the examples, again, is, and I think I used it on the PowerPoint, is physical health. So that may include sleep patterns, diet. You may find out that there's 2 or 3 different measures that actually have patterns and become physical health. So one's the more in-depth subjective aspect that looks at patterns, and one, the factor analysis, principal component analysis, actually looks at, from a quantitative standpoint, a statistical standpoint, patterns in measured variables that would then describe a latent variable. Similarities and differences. So that if that kind of gives you a little bit of an overview for what that assignment is about, that's just the broad definition of it. All right, let's go back to all right, factor analysis, principal component analysis. They're both very similar. They're very similar in how they're run. The differences are fairly complex. So right now, you'll oftentimes see them used interchangeably, but there's some subtle differences in them. But the overall concepts are going to be the same for them. So we use them to understand the structure of a set of variables, and the variables is for a latent variable. And like right here, maybe we want to measure burnout. But can we actually measure burnout in and of itself? Or are there other variables that set up a pattern to say this is what burnout looks like? That's what latent. Latent means it's underlying. It's not obvious. Okay. So we're going to use these types of statistical analysis to reduce that data set to more manageable factors or more manageable components. instead of having a test that has 65 questions on it, and many of those may be measuring the same concept, we can use this statistical analysis to bring that test, those questions down to the least number possible. So that's part of what we use factor analysis for. And again, that multicollinearity, where you may have 2 or 3 tests that are kind of measuring the same concept. So you get that multicollinearity, they're highly correlated with each other. Then in a factor analysis, we can actually look at eliminating some of those questions and creating this new factor to measure that. So they reduce a set of variables into a smaller set of dimensions is what they do. That word parsimony, I just love that word parsimony. You want the most impact with the least amount of complexity, basically, is what that stands for. And again, so these are the latent variables or the factors that we're trying to explain with the least amount of measurement possible. So it's always the latent variables. And what's going to happen when we do this, there's going to be a matrix that's going to actually be produced. And that contains the correlation coefficients. And that's how we determine which factors to keep and which factors not to keep based on this. And this will make more sense. I do need to find a good set of data for us to run this on. So it'll make a lot of sense when we do that. And I'll have that ready next week. But this is just the concepts behind it. So one of the examples is, so let's say the example is we want to measure stress among college students on a college campus. So how do we measure stress? Okay, we've got to come up with a way of studying it. And what question would we ask? What data would we gather? Well, there are some stress measurements. Most of your scaled instruments that are already out there that you can get that come and they have the reliability and the validity. A lot of them have already been through the psychometrics of factor analysis, okay? So we're gonna kind of pretend like we're doing something and it's not been through that already, that there's not a measurement out there for it. So maybe we ask students for information about the demands of their academic program, their course load, the difficulty level. We ask them about volunteering, their committee, their job commitments. We ask them about their physical exercise, their diet, their sleep patterns, the number of days they're off sick. There's emotional states, psychological outlooks, worry, optimism, social connectedness. So there's a lot of things that we can measure that we feel like may be indicating levels of stress, okay? So we could use a factor analysis and it would show us that answers related to their commute, their paid work, their extracurricular activities have a pattern. They share a pattern, okay? So they're correlated with one another. So in our sample, these things are correlated with one another. And maybe we determine that the underlying concept, the latent variable that is actually being measured by what they're reporting in terms of their commuting, their paid work, their extracurricular activities, could be seen as time pressure or time availability. So because of what they're saying here and these 3 different variables we're looking at, these 3 different measures, we determine that those are actually telling us about time pressure or time availability. That is our factor. So then we go back and we do an analysis of those 3 different measures and determine which questions of those are actually contributing to that factor. And then we may come up with 6 questions, and based on a scale of the answer of those 6 questions, we can then determine their level of time pressure, time availability. We can do the same thing for diet, sleep, exercise, and sick days. We may then find that these are actually observable and that they're contributing to the latent concept of physical health. So then we want to take these observable variables, we want to bring them down to the least amount of questions we need to ask to rate physical health. That's how we create a factor. That's what factor analysis or principal component analysis does, is it brings these observable variables down to a level where we can create a factor. And then we know if they score this on that factor or they score that on that factor, that's going to be an indication of their physical health.
So the concept that you just described, is that, so I've looked for the articles to kind of begin at least getting familiar with this, and most of them were that I found like pertain to like some formal screening or measurements that they're trying to examine. But what you kind of described, this like process of bringing like several different measurements into like a pattern or a category of its own, is that kind of like what they do with like formal assessments or instruments where, like, you know, if I'm going to measure trauma, it's like hypervigilance, but that may include not being able to sleep, you know, all these like small things. Is that kind of what that process is?
It's yes, it's kind of what the process is. So let's say I'm interested in, what did you say, Brandy? What did you say you were measuring?
Trauma.
Trauma. Okay. So I'm interested in measuring trauma. So I come up with, from other scales or from my own, 75 different questions. Because we know trauma has so many aspects to it, right? There's just so many different ones, latent type variables. Then when I do a factor analysis, it's going to tell me which of those questions are correlated, which of those questions come together. And if they're highly correlated, it means you're basically asking the same thing with two different questions. So you don't need two different questions. You just need to have the one. That's a simplistic way to explain it, but that's pretty much what it does.
That makes sense.
Okay, so when you're looking at those articles, they're almost always going to be doing the psychometrics of some type of scale, because that's what factor analysis almost is always used for, is developing scales. And you use that because you don't want to ask 75 questions and 25 of them be highly related. You're asking the same thing, just in a different way, right? So factor analysis is going to be able to tell you which ones you can eliminate and still measure the same thing.
So if like someone created, just for hypothetical purpose, like the perfect assessment, you should not see a high degree of correlation among the questions, or
it depends on how it's done. Okay. Okay, let me think of that. So the perfect assessment. Okay, so let's say we're going to measure, in the perfect assessment, we're going to measure anxiety as one of our components. Now we could have a factor that has 6 questions that, when those come together and they rank together, that indicates our level of anxiety. Okay, now it doesn't mean the questions aren't going to be correlated with each other, but they're not going to be asking the same thing. Okay, now I can have a factor scale for anxiety, and I can have a factor scale for happiness. Now the happiness and the anxiety should be totally different, right? And ideally, if I have high levels of anxiety, theoretically, you would expect I would have low levels of happiness, right? So that gets into some validity stuff in terms of content validity and criteria related validity. But what you shouldn't see in that perfect assessment is anxiety being measured by 25 different questions when several of them are asking the same thing.
okay. I think that's where my head was starting to go with validity. Like, you know, I think some things are to correlate, you know,
Right.
certain constructs. Okay.
Yeah, and when we get into validity, it's close. I mean, we're right there on the edge of it because it's kind of the same thing. Are we measuring what we say we're measuring? Okay, but what factor analysis does, or principal component analysis does, is it just brings down those, essentially the questions we have to ask to measure that latent variable. Because we know with our physical health that we can measure our sleep patterns, our dietary patterns, we can measure our blood pressure, we can measure whatever that looks like. We can do all those individual measures, but what we'll notice is there's patterns there. And when we pull those together, it really gives us a measurement of our physical health. So we need all of those in that factor to give us a good, complete measure of our physical health, but we don't need the 50 questions from each one. Okay, so it's just trying to get it down to what we really need to ask. And see, when you're doing qualitative research, you're doing something very similar, but you're asking the individual for their subjective experience of physical health. Tell me what physical health means to you. And they start describing it. And then as you're doing the qualitative analysis, you start picking up the patterns that are going to be similar. So qualitative feeds into the quantitative, then the quantitative is going to actually grow to the point where you can come back to a factor analysis and get that down to parsimony. So you're just measuring the bare bones of what you need to measure for that latent variable. Does that help some? Okay. I'm going to try to find a good example for us to run it, and then that'll help too. There's actually two types of factor analysis. One is exploratory factor analysis. And this is actually kind of open-ended, and you discover the structure of your data and what variables do group together. So you kind of go into exploratory factor analysis without a preconceived idea. Confirmatory factor analysis, you've already got theory or hypothesis about those variables and the latent factors, and you're going to be looking for very specific relationships in there, because you're wanting to see if your data supports your theory. So it's more of a testing. Exploratory is really kind of exploratory. How does this data fit together? What do these patterns look like? Confirmatory is exactly what it says. You're trying to confirm your hypothesis, your theory, that these are the patterns that happen in these variables. So like I said, factor analysis, principal component analysis, they really just aim to reduce that correlation matrix into a smaller set of dimensions. Just we have less possibility to make mistakes if we have fewer things to measure. So we want things to be as parsimonious as possible. We just want we want to get the most bang for our buck with the least amount of measurements as possible. And that's the best way to think about factor analysis and principal component analysis. In factor analysis, it is the dimensions or the factors. They're estimated from the data, and they're believed to reflect the constructs that can't be measured. In PCA, it transforms the data into the linear components, and it just transforms the measured ones. It does not estimate unmeasured variables. That will become clearer as we get more in depth into this. But they do both look for the variables to correlate highly with a group of other variables. If the variables aren't correlating, then you need separate measures. If they're correlating and they're highly correlated, then you can reduce those measures and you can get the same answer, the same definitive response from fewer questions. Whew, that was a lot. Any questions about anything? at this point. So next week, I will post this recording. I'll post the, I'll add this particular PowerPoint. I'll add the new data set to our D2L. If we go into more depth next week for factor analysis, is there anything else you want me to go over at this point in time that you have questions about? Oh, okay. One thing, and I meant to put on the PowerPoint so I wouldn't forget. I've had some questions, and so I want to do a little clarification, because in the homework assignments, it says be sure to use APA style, okay? Let me tell you what this means to me from the APA standpoint. And the only things that I think you need to worry about, because as we move forward, I want you to always be practicing to write the responses in your homework like you would if you were writing them for a publication, because that's the best way to learn how to write these, you know. So if for some reason the homework says what's the mean, the median, and the mode, I don't want bullet statements. I want you to go ahead and try to flesh that out and put that into some type of 2 or 3 sentences, a paragraph, make a story of it, okay, so we can get that practice. Number one, APA is always about citations. No matter what class you take, no matter what you write, APA consistent across everything should be about your in-text and your reference citations, period, okay? From there, you want to look at, for statistic purposes, on page 178 in the new manual, it starts talking about numbers and how you express numbers, when you use numerals, when you use words, when you can combine them, that type of thing. Statistical mathematic copy, it talks about some different ways to do that, some references, some things like that. That would be the APA aspect of it, you know, how to do the abbreviation or the symbols on your statistical abbreviations. And then tables and figures. It talks about how to do tables and figures, how to construct those. Those are APA guidelines. Also, in SPSS, when you get ready to export your tables, do y'all know how to do that? Do you know how to export your output? When you do that, there's a thing you can check and it will say export it in APA format. Okay. You never want to cut and paste from SPSS into your papers. You always want those tables to be formatted according to APA. What I will caution you is if you use that automatic and you say export it in APA format, go back and double check against the book to make sure it does. Because sometimes when you use the templates and things like that, it's not just exact. But you should only be using APA tables within your papers, okay? So just start practicing on that now. If you want in your homework, if you're wanting to present a table, if you're wanting to do something, I want you to do it according to what it would look like if you were actually sending that in for publication, okay? I think in homework 3, I made some specifications to that. I said attach your output because I want to see what you ran just to make sure that you're running it correctly so that if I need to go back and show you something different, I can. But in the write-ups, I want you to really start practicing on how you would write those results up in a paper, okay? Does that clear up any of the APA questions? Because I know I've had some specific APA questions, and so I wanted to clear that up for everybody on that part.
It does, but so like an actual write-up, I think I probably missed that part, but an actual example of a write-up, did you put that in this PowerPoint?
I do not have one in this PowerPoint. I will go back and add it for a write-up for the chi-square and for the
Okay.
I did not put those two. Last week, I think I did add them in, but I'll make sure I go back. I did not this time, but I will go back before I post the PowerPoint and add those here
Okay, thank you.
on that part. Yes, thank you, Erica. I will be sure to do that. Any other questions at this point? Ooh, your mind's all just going with the statistics. Really and truly, guys, I know it can seem overwhelming, but it's really just a tool. It's just a tool that we use, again, to tell our stories from our data. So think about it like that and try not to get too overwhelmed with it. It'll come. It comes more the more you do it, the more you practice it. As you're doing, when you start doing your dissertation and you start going through your data, pull out your references, pull out your books, look things up. Do not expect yourself to know it the first time, just writing it in there. I've been doing it for years. I still have to look up a ton of stuff. I know the basics, to go into, but then when I need to do something that's just not standard, I needed references. I've got to go back and look things up. So give yourself permission to do that. Don't think you're supposed to be able to memorize all this and know it all and be able to just pull it off the top. Now, when you get your data, like I said last week, though, when you get your data and you're defending your data, you need to do that. But as you're working through your data, give yourself permission to look things up and go to different resources to do it. Don't think you have to know it all on your own. Anything else for tonight? Whew, y'all are a quiet bunch tonight. Stop the share.
Thank you, Dr. Judd.
Thank you. And like I said, if you have any questions between now and next week, let me know. If we need to meet, I can do it. I'm more than happy to, and we can go over things. Whatever we need to do to help clear it and keep it cleared up for you. Okay?
Got it.
All right. And I have made a vow that I will get this class posted in the morning. So I will do that. Anything else? All right. Y'all have a great rest of the evening.
Thank you.
Bye. Great rest of the week.